This is the first section in the series chapter from the Core 1 book, and it's the sums of natural numbers. Okay, so the first thing that we need to know is about this sigma notation. So sigma notation. So sigma is another Greek letter. Okay, and we use it in maths to stand for the sum of. It's the sum of the stuff that comes after it. So you may be familiar with this when we work out the mean. Yeah, so the top bit means the sum of, where you do f times x first, and then you add all of those f times x together, and this means the sum of frequencies. Yeah. Now what we can add to sigma is some algebra. So if I added something like this, say this, and I put r here, what it means is that r, the first time round is going to be 1. Okay, so this number I've got at the bottom here. Okay, so r is starting with 1, and then I'm finding the sum of all of the r's from 1, 2, 3, 4, 5, 6, and I stop at 7. Yeah, here. So you can think of here as this being like your starting value, and here this is our finishing value, our end value. Yeah. Now instead, if this said, instead of r, if it said 2r, okay, then this means, well, this time I'll start with 2 times r2, 2 times 2, 2 times 3, whoops, 2 times 3, should know what 2 times 3 is, it's not a comma because we're adding together, 2 times 3, 2 times 4, 2 times 5, 2 times 6, 2 times 7, so it would be that. Yeah, adding those together. When we add things like this together, it's called a series. Yeah, so maybe we should write that down, that the sum of a sequence, we've got a sequence of numbers, we add them all together, is called a series. It's called a series. This chapter is all about series, about finding the sum of these different things. We'll do one more. Let's say instead of 2r, instead there I had r squared. Let's put that down first before I do the equals r squared. Okay, so this will be 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus 6 squared plus 7 squared. Okay, so we can do what we like with r. We can change it to anything we like. And what we've got are certain rules that help us to work out the sums of certain sequences really easily. Okay, so the first one is this, and we'll go for each one and say what it means. So it's the sum of r equals 1 to n of 1. Now what does this mean? It means we're doing 1 plus 1 plus 1 like this, and we're doing this n times. Yeah, because the top number is n, and it basically just tells you how many times to add the ones together, and that is just equal to n. Yeah, so the sum of r equals 1 to n of the number 1 is just n. If you add n ones together, you get the number n. So that's the first one. Okay, the second one is not just 1, but the counting numbers. So I'm going to go r equals 1 to n. This time I put r here. And what does this mean? This means 1 plus 2 plus 3 because r changes, plus dot dot dot, all the way up to n. Now what this equals is half n plus 1. Now you will prove this in your normal maths lesson, so I won't go through the proof here, it's not particularly difficult. But you do need to remember this, that the sum of r equals 1 to n of r is half n plus 1. So this is the other formula that we can use, and you need to remember these two. There are others that we'll go through, but you will be given those in the formula booklet. Right, so each one of these we're going to evaluate each one of these series. Now for the first one, because it's just 4 terms, I don't need the formula or any type of formula for that in part A. So I'm finding the sum of r equals 1 to 4. So it's only 4 terms of 2r minus 1. Right, so what does that mean? 2 times 1 minus 1, that's the first term, plus, so you can see there's r, 2 times 2 minus 1, plus 2 times 3 minus 1. So can you see r changing up to 4? 2 times 4, it's gone up to the top value, minus 1. So all we need to do is to work this out. So the first number is going to be 2 minus 1, which is just 1. The second bracket is going to be 4 minus 1. The third bracket is going to be 6 minus 1. And the last bracket is going to be 8 minus 1. So that is just 1 plus 3 plus 5 plus 7. So that's 16. Okay, so I didn't need a formula, but it just helps you see what the rule is doing. Part B. So on this one, r equals 1 to 50. Now I am going to use the formula for this because I don't want to be writing out 50 terms and adding them up. So I'm just going to write down what this actually means, and then we'll use the formula. So this means 1 plus 2 plus 3. Yeah, we're adding all the numbers basically up to 50. Now you wouldn't need to do this, but I'm just writing it out so you can see what's going on. And the formula for that is half n. Now where's n? N is up here. That's where you're going to find n. Okay, so it's going to be half n, so half times 50 times by n plus 1, so 50 plus 1. Right, so what's that? 25 times by 51. If I work that out, 25 times by 51, I get 1,275. So if I were to do this manually and do 1 plus 2 plus 3 all the way up to 50, that's the number I get. The formula makes it quicker. And then part C, I'm finding the sum from 21 to 50 of r. Right, now this actually means like 21 plus 22, okay, up to 50. Now there's a little trick we can use. I'm going to find the sum from 1 to 50, like this, which I have done already, but subtract the sum from 1 to 20. Yeah, that will just leave me with the sum from 21 to 50. So that's the trick that we use. So always find the sum from, not summy, the sum from r equals 1. Really important. Always find the sum from r equals 1. And then we can use that to work out the sum from any number. A bit like when you do, if you had a question in binomial or Poisson and you wanted to find the probability from 21 to 50. Right, then what would you do? You would find the sum, or you find the probabilities from up to 50, yeah? And then you take off the probability up to 20. It's the same principle. Yeah, taking off the ones that you don't want. So the same technique that you used here, just tie that up, 21 there, when you did binomial or Poisson, yeah, we do here, because it's basically like we can only find the formula gives you like the cumulative sum from 1. Okay, so let's work this out. So we've already worked out the sum from 1 to 50. We did that in part B. So this was what we worked out here. So we've done that already. So we just can just write 1275, and then minus half n. So for the second one, it's going to be 20 times by n plus 1, 21. Yeah. So this is the sum of this bit here. Right, so what does that give us? 1275 minus, now half of 20 is 10, 10 times 21, 210. So 1275 minus 210 gives us 1065. Okay, up in the corner in a blue box, that's basically what we talked about in the previous example 1C. Right, so show that, right, so we need to start with this side and use our rules to get us to the other side. So our rules are that these, the sum of 1 to n is n of all the ones, and the sum of 1 to n of r is half n times by n plus 1. So let's use those. Now notice I've got the sum from 5, so I need to find the sum from 1 to 2n minus 1 and subtract the sum from 1 to 4. Not to 5, but to 4. I want to carry on from 5 onwards, but I don't want the first 4. Right, so for the first part, we'll plug in the formula. So that's going to be, oh, sorry, I missed the r's. There should be r there and r here. So basically, the question we started equals that. That will equal half. So for the first one, half n. So that's 2n plus 1 or 2n minus 1. Half n times by n plus 1. So that's the top value, 2n minus 1 plus 1. Okay, so this here relates to this, the first part. Now minus, we're now going to do this second part here. I'll just do it in a different colour just to make it a bit clearer. So this is going to be half n times by n minus 1, or sorry, n plus 1. So it'll be 5, like this. Yeah? Right, so from here, let's put on that, we're going to tidy this up, expand the brackets, and see what we get. So the rest is just algebraic. And once we've done the algebra, we should end up with this. The n greater than 3 just ensures that we don't end up with negatives, I think, in our sequence. I think that's what it's there for, but that actually won't form part of the answer. So let me just highlight the bit that we will get. So we're looking to get this as our answer once we've expanded the brackets and tidied everything up. Right, let's do that. So half, so if I expand the brackets, I will get 4 big N squared. Now this becomes 0, doesn't it? So I won't bother with that. and then minus 2n minus, now half of 4 is 2, 2 times 5 is 10 minus 10. Right, so we halve the things in the brackets, so that's 2n squared minus n minus 10 as required. There we go, as required. So we did it. Okay, here's another one. Evaluate between 1 and 25, 3r plus 1. Now what we can do, there's some stuff in the red box here, but I'll try and explain a slightly different way. If I've got, so we know that the sum from 1 to n of r is half n times by n plus 1. Yeah, so we know that already, half n plus 1. Now what if I had the sum of 3r? What do I do then? Do I put 3r in? How does that work? Well, what we can do is we can move the 3 to the front. So it's the same as the sum of 3 lots of r from r minus 1 to n. What if I had half r from r equals 1 to n? Well, this is the same as half the sum of r. So can you see this constant can go at the front? Yeah. Now, probably a little quick proof to show you. So let's say the sum of r equals 1 to 5 of r would be 1 plus 2 plus 3 plus 4 plus 5. The sum of r equals 1 to 5 of 3r, okay, would be 3 plus 6 plus 9 plus 12 plus 15, which is equal to 3 lots of 1 plus 2 plus 3 plus 4 plus 5. That's why we can put this 3 at the front, yeah, because it's like basically 3 times what it would be if it was n. Okay, that's the first rule that we have. The second rule that we have is sometimes you get the sum of a mixture of things. So far we've just had the sum of r's or the sum of numbers. What if I had something like this? The sum of 2r plus 7. Well, this is equal to the sum of the 2r's plus the sum of the 7's. R equals 1, not n equals 1. Yeah, so you can split them up like that, and then we can bring those multiples to the front. So it's 2 lots of the sum of r equals 1 to n of r plus 7 lots of the sum of r equals 1 to n of 1's. Then this would become something like 2 lots of half n times by n plus 1 to work out the r bit, plus 7 lots of the n. So these bits here, these are just the rules from before. Yeah, the multiples came from here, and what we were able to do was to take this whole thing here and split it up like this. So we can now use all of those rules, which are basically summarized in the box at the top, to take more complex sums and almost like expand them and use those to help answer questions. Right, so let's clear off some space so that you know where my working stops. So hopefully there should be enough space to work out our answer. I'll do it in a different color so that separates it from the explanation at the bottom. Right, so this, the sum of r equals 1 to 25, 3r plus 1 is equal to the sum of 3r from r equals 1 to 25 plus the sum of 1 from r equals 1 to 25. Now we can take that multiple of 3 and put it at the front. So the sum of r from 1 to 25 plus, well, there's no multiple here, so we'll just leave that as 1. Just write a 1 like that. From r equals 1 to 25. Now we can use the formulae. So it's going to be 3 times half n times by n plus 1 plus, it's just n, isn't it, 25. Right, so let's work that out. So I'll do the 25 times 26 first, which is 650. I want half of that, which is 325. Times that by 3, then add 25, and I get exactly 1,000. Let's put that in, 1,000. So can you see how we've used these rules to basically break it down so that we use the formulae either for the sum of ones or the sum of r. Right, part A, show that that sum is equal to that. Right, so here we use our rules in part A. So the sum of r equals 1 to n of 7r minus 4, well, that's equal to 7 sums of r from 1 to n minus 4 sums of 1 from r equals 1 to n. So that'll be the first step. So that will be equal to 7 times r half n times by n plus 1 minus 4 lots of r sums of 1s. Okay, so that's that. I'm guessing now we just expand the brackets. So we're going to have 7 times in brackets half n squared plus half n. Well, it's not 1 over n, half n. Minus 4n. Now let's expand the brackets, and it looks like we need to refactorize it with half n outside. So we'll get 7 over 2 n squared plus 7 over 2n minus 4n. Now that 4n, let's have a look. Well, these two are going to go together, aren't they? Yeah. So that will give us 7 over 2 n squared. So 7 over 2 is like 3.5. So 3.5 minus 4 gives me negative a half. So negative a half. N. This can be refactorized with half n outside. Just leaving me with 7n minus 1 as required. Okay. Whenever you've got proof questions, don't just try and skip steps and cheat and just write the answer down in the hope that you'll get it right, because when the examiners mark papers, there's a little asterisk by the answer that tells them don't just look at the answer to get the mark, look back at the working. So that tells them, all right, just because you've got that there, it's not right, it's a proof question. And then part B says, hence evaluate that sum from 20 to 50. Okay, well, we've already worked out what its value is. So the sum of 20 to 50. So we're not going to do this from scratch. We're going to use what we did from part A. 7r minus 4. Well, that's equal to the sum from 1 to 50. 7r minus 4. Take away the sum from 1 to 19, not 20, 19. 7r minus 4. So now we can just substitute in. So the sum to 1 to 50 is going to be this, but with 50 in it. So that'll be half times 50 times by 7 times 50 minus 1. Okay, so that's the first bit. And then minus the same formula, but now we put 19 in. So half times 19, and then in brackets 7 times 19 minus 1. Okay, so let's work this out a bit at a time. So I'm just going to work out the first bracket. So I've got half times by 50 times by 7 times 50 minus 1. So that's 8725, the first bracket. Minus, now what I'm going to do is scroll back, delete the 50s and put 19s there. And I get 1254. So 8725 minus my answer, 7471. 7471. There we go. Right, you should now be able to do exercise 3A on pages 46 to 47. So these are the formulae. The sum from r equals 1 to n of 1s is n. The sum equals r equals 1 to n of r is half n, n plus 1. And then we've got those rules where we can split things up. So if I had the sum of something times by 1, let's call it a, that will be equal to a times by the sum of my 1s. And if I had the sum of r equals 1 to n of br, for example, then the b can go at the front. 1 to n, and then what that means is this bit here I can work out using the formula, and this bit here I can work out using the formula, and then it's just a matter of multiplying by a or b afterwards.